Let us see the topic on association rule mining. So far we are seeing the concepts behind the machine learning. Okay. So in the last session we have uh, deal with the classification algorithms. Okay. Decision-tree algorithm, then naive-bayes algorithm. Uh, then we have seen so many classification algorithm, then logistic, that is regression, then we have compared with the classification and the regression also. Today we are going to see the association rule mining, which comes under the unsupervised machine learning algorithm. Okay, so unsupervised machine learning algorithm means we don't have any guidance or no labeled data with them. Okay, as already we have seen the comparison with the supervised machine learning algorithm and the unsupervised. Okay, so association rule mining comes under the unsupervised learning algorithm, machine learning algorithm. So the objective of the session is to make you known about the basics of association rule mining. By short, we call that as ARM. Okay, and the outcome of the session is to make the students understand the concepts behind association rule mining. And these are the outlines of today's session. So first, we'll be seeing about what is meant by a descriptive information and predictive information or model. That is the comparison of descriptive model and the predictive model. Okay, and next we'll be seeing the introduction part of the association rule mining, and we'll be seeing what is meant by association rule mining and where we can apply this association rule mining. And the best example for association rule mining is market basket analysis. We'll be dealing with that. Okay, and there are some definitions related with the market basket analysis. We'll be seeing the definition part of frequent item set, and we'll be dealing about how to frame the association rule and what is meant by association rule, all these things. Okay, and the algorithm to find the frequent item sets. There are two kinds of algorithm we are going to see. The first one is a priori algorithm and the second one is FP growth algorithm. FP means frequent pattern growth algorithm. Okay, so with this, then we will be seeing the comparison between the a priori algorithm and the FP growth algorithm. With this, we'll wind up the today's session. Okay, fine. Okay, so coming on to the descriptive model and predictive model. Okay, so descriptive in the sense it is all about unsupervised machine learning algorithm. Okay, so first of all, from data mining means it is all discovering about the hidden patterns or interesting data or information. That is called as data mining. That is uncovering and discovering the hidden useful information, that is interesting information, that is relevant information from the data. That is going to be called as the data mining. Okay. Descriptive information means find the patterns that are human interpretable. Interpretable, so what are all the things which is understandable by the human beings, that is going to be interpretable. Okay, so finding the patterns that are human understandable, that is called as descriptive information. So the best example for descriptive model is clustering, association, rule mining. So these two are the example for unsupervised learning algorithm. Okay, next coming on to the predictive information. In the predictive information, we'll be finding the values of an attribute from the other values of the attribute. Okay, so this is all about a supervised machine learning algorithm. So predictive model is the task of classifying and predicting the labeled outputs from the given input to the user. Okay, so the best example for predictive model is classification and regression. Okay, so descriptive is nothing but unsupervised, and predictive information or predictive model is about supervised learning algorithm. Okay, so here are some of the widely used association rules application is the best one is market basket analysis. Okay, So in market basket analysis, we'll be finding the frequent patterns. So what do you mean by frequent patterns? Mean the patterns that appear in the data set frequently. That is the occurrence of the patterns appearing frequently. That is called as frequent patterns. Okay. For example, if the milk and bread that appear frequently in a transaction data set, so that milk and bread is going to be called as a frequent pattern. So the other names that could be called as frequent item set mining, association rule mining, market basket analysis, and link analysis, etc. Okay. See here, what is market basket analysis is that a customer going to a shop willing to buy so many items or items or products. Okay. So the customer one is willing to buy milk, bread, cereal. So if the customer one is tends to buy milk, then he will also buy the other product, that is bread and cereal. Likewise, customer two is buying some other products, milk, bread, sugar, eggs, like that. So all these are called as the baskets containing several number of items are there. So every customer is buying their own products. So the retail shopper will identify, or he will be observing the buying characteristics of the customers. So based on that, he could improve the performance of the shopping. Okay. Okay. So what is Milde association rule mining? So this was the proposed by a person called Agarwal et al. So not only by only one person, some combined persons have been proposed this association rule mining. So that's why it has been described as et al. Okay, in the year 1993, and this was the important data mining model studied extensively by the database and data mining community. Okay, so here all the data will be in the form of categorical. So categorical will be in yes or no format or true or false format, likewise. Okay, so it is not all about a numerical value. Okay, so it's no good algorithm for numeric data, so it won't have any numerical data. Okay, so initially this association rule mining was used for the market basket analysis to find how items purchased by the customers are related. Okay, see here, if the customer buy the bread item, he will also buy the milk also. Okay, and the support of this association, this is called as association rule. Okay, so this rule is based on the support of this rule is 5% and the confidence of this rule is 100%. We'll see what is this support and confidence. So these are the measures to find the association rule. Okay, so what is association mining? So mining, in the sense, you are going to find some interesting patterns, likewise. Okay, so the motivation of this association mining is finding the regularities in the data. Okay, so what is the regularity kind is that what are the products were being purchased together. So for example, if the customer is buying beer, so along with that beer, he will also may also buy the diaper. Okay, okay, and what are the subsequent purchases after buying a personal computer, likewise. Okay, so if the customer is buying the personal computer, he might also buy the antivirus softwares, like that. Okay, and he may or might also buy the pen drive, like this. What are the other subsequent purchases after buying a PC? Okay, and what kinds of DNA are sensitive to this new drug? Okay, and these are all the problems related with the association mining. Can we automatically classify the web documents? So for all these, we can go for applying this association rule mining algorithm. Okay, so by definition, we can define this association mining as finding the frequent patterns finding the frequent associations, correlations, or causal structures that exist among the set of items or objects in the transactional database or relational database and other information repositories. Okay, so the major applications of association rule mining are basket data analysis, cross marketing, catalog design. For all these applications, we can go for applying the association rule mining algorithms. Okay, so where we can apply this association rule mining, the applications of basket analysis, telecommunication. So in telecommunication, each customer is going to be a transaction which will be containing the transaction will be containing the set of phone calls. Okay, and credit calls, banking services. So each credit card is going to be considered as a transaction which is consisting of a set of customer payments. Okay, and medical treatments. Each patient is treated as the represented as a transaction containing some. This transaction will be containing some set of ordered set of diseases. Okay, and basketball game analysis. In this, each game is represented as a transaction containing some set of or ball passes. So like this, each and every application is going to be considered as a transaction which is consisting of some set of customer payments. Depending on the application, it can be. Okay. So what is meant by market basket analysis? The input for this market basket analysis will be some list of purchases by the customer or the purchases. Okay. And in this market basket analysis, the main objective is to identify the purchase patterns. How far the customer is going to buy the products in a shopping mall, like that. Okay, and what items tend to be purchased together. For example, if he is buying a milk, then he might also buy the butter, likewise bread. Okay, and what items are purchased sequentially. Okay, and what items tend to be purchased by seasonally. Okay, so all these purchasing behavior will be analyzed by the shopkeeper. Okay, so in this market basket analysis, one of the key techniques used by the large retailers to uncover the association between the items. Okay, to discover the association between the products. Okay, so if the person is meant to buy the bread, he might also buy the jam. So bread and jam. So these items are purchased together by the customer. So likewise, the laptop, if he buys the laptop, then the laptop bag, he might also buy the laptop bag, likewise. Okay, and bread and butter. And if he is buying the egg, some offer is also being announced. Okay, like this. So these were some of the market basket transactions. Okay, so this is a list of transactions is depicted here. So this list of transaction, we call this as a database. Okay, and in the database, each one is called as transaction. So this first represents transaction 1. In the transaction 1, it is having some list of items purchased by the customer 1. Okay, and the transaction 2, some other products purchased by the transaction, that is by the customer, another customer. Okay, so likewise, so many transactions are there. Each transaction is consisting of some list of products or items. Okay. Okay. So coming on to the association rule concept, rule mining concept. So you will be given some set of transactions. Okay. And you need to find, the objective is to find the association rules. So that will predict the occurrence of an item based on the occurrence of the other items in the transaction. Okay. For example, if you are given a market basket transaction like this, and here or the database is given, and in this database you are having 5 transactions listed by transaction ID 1, 2, 3, 4, 5. Fine. And each transaction, the items bought or listed here. So in the transaction 1, bread and milk were purchased. Okay. So from this transaction, you might go for forming the association rule, like if the customer is buying diaper, he might also buy the beer. So this is one kind of rule. Okay, and if the customer is buying milk and bread, he might also buy egg and coke. So these are some of the rules. Okay. So what is basket data? So in a market basket analysis, in the prior slide we have seen, so each basket will be containing some list of products or items. Okay. So the retail organization or the supermarkets will collect some amount of data that is called as basket data. Okay. So a record will be consisting of transaction date and the items bought. Okay. So record in the sense particular row in the transaction table. Okay. Or the basket data may consisting of some number of items which is bought by the customer over a period of time. Okay. So with the items frequently purchased together, you can go for framing the association rule. If the customer buys the bread, then he might also buy the peanut butter. Okay. Okay. So we have to frame the association rule. Okay, that's the main motive of this. Okay, so this association rule consisting of two parts. One is called as antecedent, that is called as if part. Okay, and this next part is called as consequent, that is called as then. Okay, so an antecedent means this is the item found in the data, and consequently it is also an item found in combination with the antecedent. Okay, so the rule is going to be like a kind of syntax, like antecedent implies the consequence. Okay, so you will be given as some database of transaction, and each transaction will be consisting of some list of items purchased by the customer in a visit. Okay, now the task is to find the association rule or frame the association rule that correlate the presence of one set of items with that another set of items. For example, 98% of the people who purchase tires and auto accessories also get the automated service system. So if the person is buying tire and auto accessories, he might also given some service. Okay, service offers also. Okay, so as we have seen, the another example, 90% of the transaction that purchase bread and butter. So if the customer is buying bread and butter, he might also purchase milk. Okay. Uh, okay. So in this association rule, the bread and butter will be called as antecedent part, and this milk is going to be called as consequent part. Okay, so if part is called as antecedent and then part is called as consequent. So if the person is buying bread and butter, then he will also buy the milk. Okay, so always note a point that antecedent and consequent are just disjoint. What does mean by disjoint? That is, we don't have any items in common. Okay, and the confidence factor. So he will surely buy this 90% confidence level that he will surely buy the milk, like that. Okay. So from the given database, you can find this so and so association rule. Okay. So you'll be given a set of transaction. You have to go for finding the rules that will predict the occurrence of the items, frequent items, based on the occurrence of the other items in the transaction. Okay. So what are the measures to be followed or measures to be adopted to find the association rule? So already we have seen the rule is going to be like this. If A, then B. So this if part is going to be called as antecedent, and then part is going to be called as consequent. Already we have seen. So the measures of association rule mining are three measures are there. One is called as support measure, the other one is called confidence, the other one is called as lift. Okay. Now we are going to see how to calculate the support, confidence and lift. There are some formulas to calculate these three measures for association rule mining. So the support is calculated by the formula, the frequency of A and B divided by the total number of transactions, that is represented as n. Okay, and coming on to the confidence, okay, it is calculated by the frequency of A and B divided by the frequency of A. Okay, and lift is calculated by support divided by support of A in support of B. Okay, so coming on to the definition part of the frequent item set. So here is the your database is given. So database means collections of transactions or set of transactions is called as database. And this each one is called as transaction 1, transaction 2 likewise. And each transaction will be containing some set of items. So what is item set? A collection of one or more items that is going to be called as item set. For example, milk, bread, jam, likewise. So K item set means an item set that contains K number of items. For example, if it is containing 2 item set, then item set will contain 2 items. Okay. How do you calculate the support count? It is represented by the sigma. Okay. So support count means the frequency of occurrence of an item set. So how much frequently the item set is occurred. Okay. So for example, find the support count of milk bread. See here, milk bread is in the first transaction. Number of count is 1. Milk bread is also in the second transaction, 2. Then you are having in the 5th transaction milk bread. Okay, 3rd count. That's all. So number of occurrence of milk and bread in the transaction database is 3. So this is called a support count. And find the support count of soda and chips. The number of occurrence of soda and chips by combination in the transaction, you have to find the count. Okay, so that is 4. So what else will be support? So first you need to go for calculating the support count. Next you need to find the support. So support is calculated or defined as a fraction of transaction that contain an item set. So how many total number of transaction in the database is given is 8 transaction is there. Okay, so with that you have to divide it. Okay, so support of milk and bread is that. So you have already count the support count is 3 out of how many number of transactions you are having? Totally 8. So 3 by 8. Likewise, support of soda and chips is support count is you have calculated. So how do you calculate the support? Support count of the combination divided by the total number of transactions. That is your support. Okay. So frequent item set is nothing but an item set whose support is greater than or equal to the minimum support threshold. So always you have to check out with the minimum support threshold value. So if it is satisfying the condition, then you have taken take the particular item set as a frequent item set. So all these we have seen how to calculate the support and confidence with the formula. Okay, fine. So S is nothing but the support and C is nothing but how to calculate the confidence. So S means first you have to go for calculating the support count value, how many number of bread and milk appears in the transaction, then total divided by total number of transaction. So 38% of support is have been obtained. Okay, and confidence is that support count of bread and milk divided by the support count of bread. Okay, so 75% of confidence is obtained. Okay, so support and count. Fine. We'll move on to the next. What is the goal? So the goal, once you are finding the rules, association rule is formed, then we need to go for checking with the the support should be greater than or equal to minimum support threshold value, and the confidence should be greater than or equal to the minimum confidence threshold value. Okay, so in the problem you will be given these two values, minimum support threshold value and minimum confidence threshold value. So you have to, after finding the association rule, you have to need to check with these conditions. Okay. So what does mean by brute force approach is that trial and error method that is trying out with all possible association rules. Okay. So how to find the frequent item set? So for that, we need to go with the algorithm called a priori algorithm. So a priori algorithm uses the frequent item set to generate the association rules. So the main motive of using this a priori algorithm is to find the frequent item set. So it is based on the concept of subset of the frequent item set must also be a frequent item set. That is called as a priori property. Okay. So what is frequent item set? It is an item set whose support value is greater than the threshold value. Okay. So association rule mining is going to be viewed as two-step process. First step, you need to find the frequent item set. So for finding the frequent items, there are two algorithms are followed. So the first one is called as a priori algorithm, and the second one is called as FP growth algorithm. Okay, and the second step is called as generating the strong association rules from the frequent item set. Okay. Okay. So see here, a main important to be noted here is what is in the a priori property is that all non-empty subsets of the frequent item set must also be the frequent. That's the main property. This a priori property, we need to follow this. Okay. And this a priori algorithm is a two-step process is followed. One is called as join step. The other one is called as prune step. So prune step means removing the unwanted things. Okay. So which is not satisfying this a priori property will be removed off. That kind of item set will be removed off. That is called as prune step. Okay. And join step is that you need to find the LK. So LK is nothing but the candidate's K item set. So join step is done by generating the candidate item set by joining the LK minus 1 with itself. So this set of candidates is denoted by CK. So you won't understand by theoretical. Let me move on with the problem so that you can understand very easily. Okay. So let us see this example for by applying the a priori algorithm in this example to find this to form the association rule. Okay. So apply the association rule mining to get the association rule. In that problem, the minimum support threshold value is given as 2 and the minimum confidence threshold value is given as 50%. Okay, the database is given to you with the following transaction ID and the list of items also. In each transaction, there are 9 transactions are there, and each transaction is consisting of some set of items. Okay. If this is the problem, you need to go for framing the association rule. Okay. So before moving to framing the association rule, you need to calculate the support and the confidence of each item set. Okay. So already we have seen these two are the main measures. Even though we have seen 3 measures, support, confidence and lift. Okay. So these two major plays a major role in finding the association rule, support and confidence. Okay. See here. Okay. So the first thing you need to from this given database, you need to calculate the one item set. So what are all the items in this given transaction? You can list out. I1 is there, I2, I3, I4 and I5. These 5 items are existing in each of the transactions. Okay. So one item set, we can go with only one item set. Okay. So what is meant by frequency? Need to find the number of counts that I1 is appearing in the each transaction. So here you can see here I1 is in the transaction 100 one time, then second time, third time, fourth time, fifth time, and sixth time. So 6 number of times I1 is appearing in the given transaction list. Okay. Likewise, I2. So find out the frequency of I2. So I2 here 1 time, 2 time, 3 time, 4 time, 5 time, 6 time, 7 time. Okay. So likewise, you need to find the number of counts that particular item set is appearing in the transaction. Okay, so with this you can find the first table, one item set. Okay, so now with this table you need to go by checking with the minimum support value. So what is the minimum support value given in this problem? We'll move on to the previous problem, that is minimum support threshold value is 2. So below 2 you need to prune it, that is you need to remove it. So there is no other such cases as below 2. So we have to take all the items in the second table, that we call it as frequent one item set. So if it is minimum, if the item is appearing below the minimum support threshold value, means you have to remove that or prune that particular item set. So this is not such a case in here. Okay. So we have to take all these the above table as a frequent one item set. So with this frequent one item set, next step we have to go on with finding the two item set by combining two items. Okay. Find how will you combine I1 with I2, I1 with I3, I1, I4, I1, I5. Next, I2 with I3, I2, I4, I2, I5. Next, I3, I4, I3, I5. Next, I4, I5. Next, that's all. Okay, I think so. With this, we can combine all the two item sets. Fine. Okay. Now find the frequency of count of I2, I1, I2 in the set, in the transaction list. So this is count number 1. Then here 2, 3, 4. So 4. So likewise, you have to find all the number of counts appearing in the transaction list. Next, what we have to do? You have to compare with the minimum support threshold value. Whether you are getting below 2, then you have to prune it or remove it. So find that particular item set. See here, you are getting here 1 which is below 2. Okay. Now, next 0. Next 1. So 4 rows or 4 records can be pruned. So after pruning, you will be getting the frequent 2 item set in this table. Okay. So after getting the frequent 2 item set, next thing we have to go for finding the 3 item set. With this following 2 item set, you have to go with the 3 item set. How will you find? So I2, I1, I2, I3. Okay. Then I1, I2, I5. Okay. And I2, I3, I4. I2, I3, I5. Then I2, I4, I5. So like this, with these combinations from the frequent 2 item set, you have to go with framing the 3 item set. Okay. So you can find, so see here, you can write these 5 items. With this, you can go on with the combining the 3 items. Fine. So then finding after 3 item set, you need to calculate the frequency. So frequency, see I1, I2, I3, here 1 time, and in the last transaction 1 time. So 2. The number of counts appearing, the combination of I1, I2, I3 is 2 times. Okay. Likewise, you have to find all the counts number of frequency in the 3 item set. So after finding, compare with the minimum support threshold value, which is whichever record or whichever row which is getting below 2, then that will be removed. Okay, so you will be getting only I1, I2, I3, 2, and I2, I1, I2, I5. So this 2 rows will be satisfying the minimum support threshold value. So only that 2 rows are called as frequent 3 item set. So other things you have to omit it or remove it. Fine. The next step, you have to find the 4 item set. So how will you find? See here, what are the items you are having in these 2? From this, find or combine the 4 item set. I1, I2, I3, I5. So only one possible 4 item set is there. So see the number of occurrence of I2, I1, I2, I3, I5 in the transaction is occurring only one time. So which is less than the minimum support threshold value. So you have to not proceed with the 4 item set. So with this, you can stop it here. From this, you can go for framing the strong association rule. Okay, see here, the only one possibility is this. Since the frequency number of count is less than the minimum support threshold value, so this is not possible. Fine. Okay, fine. So next thing is you have to frame or form the association rules. So what are the frequent 3 items set which we have got last step? So that is going to be called as I, which is consisting of 2 sets, consisting of 1, 2, 3 and 1, 2, 5. Okay, fine. So with this, we have to find the main thing, minimum support, that is 2 is given, and the minimum confidence is 50 is given in your problem. Okay. So 2 is okay. So with this, we have to find the non-empty subset. So what is the non-empty subset for this first set 1, 2, 3? See here, 1 individual single set, 2, 3 and 1, 2 and 1, 3 and 2, 3. So these are the non-empty subset for the first set. See, and for the second set, 1 alone, 2 alone, 5 alone, and 1, 2, 1, 5 and 2, 5. And these are the subsets. So first thing, up to which frequency set you are finding out, with that you have to find the subsets. Okay, non-empty subsets. So with this subset, now you are going to frame the rules for it, association rules. So the important thing to follow a procedure is that, yes, the rule should follow this procedure. Yes implies I minus yes. What is called as yes? So yes is nothing but the non-empty set. And what is called as I? I is nothing but the set of frequent item sets. These two are called as item set. I. Okay. So what is the thing to be followed? If the support of I divided by the support of yes greater than or equal to minimum confidence. So you have to check with it. Okay. Okay. So let us take the first set 1, 2, 3. Okay. And what are the non-empty subsets are there? List out here. Okay. And what is the first rule? How to frame the rule? Just now we have seen yes implies I minus yes. Okay. So take the first non-empty set. If this is the yes, yes implies, okay, if this is the yes, what is I? 1, 2, 3. So minus this yes, you are getting 2, 1, 3. So write it at the, this is consequent part. Okay. I think you might have understood how we are writing the rule 1. So yes on the left hand side, and right hand side you have to write I minus yes. What is I? I is the set here. I is represents 1, 2, 3. Okay. And what is yes? We have taken the first thing, first from the non-empty set, okay, non-empty subset, okay. So if 1 is on the left hand side, minus 1, you are having 2 and 3. So that should be on the right hand side. So in this we have to frame the rule 1. So now you have to find the support and the confidence, okay. So what is the support? How to calculate the support? So the number of occurrence of 1, 2, 3. So 1, 2, 3 is 2 times it is occurring. How you can see? So 1, 2, 3. See here, 1, 2, 3. The frequency count number is 2. Okay, so 2 divided by total number of transactions is 9. So you'll be getting 22.22. 22.22. That is the percentage of support. So always for every rule, the support is going to be the same. Okay. For this set, for this 1, 2, 3 set, item set. Okay, fine. Now find the confidence part. So how will you calculate the confidence? Support of 1, 2, 3 divided by support of 1. So 1, 2, 3 we have calculated 2 by 9. So what is support of 1? Go to the tabulation. Find out the frequency of one item set, that is the frequency count is 6. Okay, 6 by 9. So 9 can get cancelled. You'll be having 2 by 6. That is, you'll be getting 33.34%. That is, which is less than the 50%. So you have to compare with the given minimum support threshold value and the minimum confidence threshold value. If it is below the minimum support, minimum confidence value, threshold value means we consider this is the rule is invalid. Okay, fine. So coming on to the next rule, 2, you can take the 2 on the antecedent part. Okay. So if 2 is taken in the left hand side, what is I minus S? So you are taking 2. So leaving 2, you are having 1 and 3 on the right hand side. Okay, fine. So the support will be always same, 22.22%. Now find the confidence. So what is the support of 1, 2, 3? Already we have seen 2 by 9. So what is the support of 2? It is 7. Okay. So now we are getting the same thing, 28.57, which is less than the 50%. Okay. So now this is also an invalid rule. So likewise, we have to take the next subset is 3. So leaving 3, you are getting 1, 2 on the right hand side. Okay. Now find the confidence. Always support will be the same. Confidence, support of 1 to 3 divided by support of 3. So 2 divided by 2 by 9 divided by 5 by 9, you are getting 40%, which is also less than 50%. That is, which is less than the minimum confidence threshold value. So we have to omit this rule, which is not a valid one. So coming on to 4, the next subset, we have to take this 1, 2. Fine. So what is 1, 2? If you are taking on the left hand side, what is left? I minus S is 3 will be on the right hand side. So 1, 2 implies 3. So find the confidence. Support of 1, 2, 3 always 2 by 9. And find the support of 1, 2, that is 4. Okay. And now we are getting 50%, which is equivalent to the minimum confidence threshold value. So we can state that rule 4 is a valid one. So in this, we have to take one by one the non-empty set and frame the rule and find the support and find the confidence and check over if the confidence what you are getting, what you are obtaining is compared with that of the minimum confidence threshold value. If it is less than, then you can go for state that it is an invalid rule. If it is greater than, you can conclude that it is a valid rule. Okay. So next we have taken up with the 1, 3. So this is you are getting 50%, which is equivalent to the minimum confidence threshold value. Okay. So we consider this a valid rule. Now the last rule is rule 6, 2, 3. I minus S is 1. So you can frame 2 comma 3 implies 1. So find the confidence you are getting 66, which is greater than the minimum confidence threshold value. So this is also a variable. So in this way, you have to, so you have taken, you are getting 2 sets in the frequent 3 item set. So now, so far we are seen with the first set. The next set is containing 1 comma 2 comma 5. See here, and find the non-empty set and find the frame the rules according to S implies I minus S. So based on that, rule 1 is invalid since it is less than the minimum confidence level. Okay, and rule 2 is also invalid because 28 is less than 50%. Okay, and see here rule 3 and rule 4 are valid rule because it is greater than the minimum confidence threshold. Okay, and rule 5 and rule 6 also valid because it is greater than the minimum confidence threshold value. So in this way, you have to follow the procedures. So first we have to find the frequent item set. No, find the one item set, two item set. After finding one item set, you have to go for finding the frequent one item set, then two item set, frequent two item set, three item set, frequent three item set. So far we have to go till you are getting the minimum support value, that you have to check up with the problem what is given in your minimum support count and what is the minimum confidence count. So after finding all these, you have to go for framing the association rules. Okay, so how to frame it? S implies I minus S. So with this, you have to go for calculating the non-empty subsets with that. So you have to find how many number of rules can be obtained from the non-empty set. So with that, you have to go for checking with the support and the confidence. So if it is minimum of minimum support threshold value and minimum confidence threshold value, then you have to state that the particular rule is an invalid rule. If it is greater than the threshold values, then you can accept it. This is the concept of a priori algorithm. Okay. So this is another example you can try out by yourself. Let me move on to the FP growth algorithm. Okay, these are all the exercise that you can while posting this content, you can work out with this example. Okay, fine. The same thing, same concept is depicted here. Okay, whatever the thing with we have seen in the above example, next example is depicted here. Okay, fine. Okay. Now the next algorithm is frequent pattern growth FP algorithm. By short, we call it as FP algorithm. So FP growth algorithm is one of the algorithm used to find the frequent item sets without the candidate generation. That is the main important thing to be noted, without the candidate generation. Okay. So first thing, you have to go for compress the database representing the frequent item sets into a frequent pattern tree or FP tree. That is, you need to go for constructing the FP tree, so which retains the item set association information. Then divide the compressed database into a set of conditional database. So first thing, you have to go for constructing the FP tree. The next thing, you have to go for constructing the conditional databases. Okay. So in this database, each one will be associated with the one frequent item or the frequent fragment. Okay. Okay, let's see with one example. Then we compare the a priori algorithm, and if we grow, then we'll wind up the session. So here you are given a 9 transaction consisting of so many items in each transactions. Okay. So the main objective in FP growth is that first point, you have to go with finding the constructing the or generating the FP tree to find the frequent item sets. So in FP growth algorithm, you need not go for finding the candidate generation. Okay. See here. So the given minimum support threshold value is 2. Okay. So first thing you have to scan the D. D means this is the database. So this is called as D. This is the database. You have to scan the D for count of each candidate. Okay. So what are the items in this listed in this database? See here A, B, C, D, E. So 5 items are listed in it. So first we have to generate the so how many each items are appearing in this transaction, we have to find it out. Okay. So A is having, sorry, I have moved to the next one. Okay, fine, no problem. So A is occurring in 1. Okay, 1, 2, 3, 4, 5, 6. So 6 times occurring. So likewise, you have to find the other items, number of counts appearing in the transaction. So after finding, you need to do is you have to sort the frequent items in frequency descending order. You have to write it in a descending order. So see here, if you are writing in a descending order, B item will come first because it is having the support count value as 7. So the next tabulation you will be ordering in a sorted order, having in the having the count in a descending order. Okay, so B is having the top value 7, A, C, D. Likewise, it is coming in a descending order. Fine. Next thing. So after listing out, you have to add up with one more column, that is ordered item set. So based on the sorted items listed in the prior table, you have to order the following items. See here A, B, E. So in this, which one will come based on this support count? B will be having the highest count. So you have to rewrite this order like B, A, E. Fine. Because B is having support count value 7 and A is having support count value 6 and E is having support count value 2. So in this manner, see the next transaction BD. So what is the support count of B? 7. What is the support count value of D? Is 2. So 7, 2, it is already in the correct order only. So you can replace the same order in the order item set. So like this, B is having 7, C is having 6. So 7, 6 is in the correct order. See A, B, D. A is having 6, B is having 7, D is having 2. So you have to rewrite this order based on the sorted order here. Okay, so you have to write it as BAD. Likewise, you have to rewrite all the orders depending on this sorted frequency. Sorted descending order. Okay. So after doing this, we need to generate a FP tree. Okay. So what is this? Now you are going to draw a FP tree. So for that FP tree, you need to go with the constructing a header table. HT is header table. Okay. So see the table, whatever things we have sorted here. So same table is depicted here. Now with this, add one more column to draw the FP tree, that is node link. So okay. Now always a tree should start with the empty set. Okay, fine. Okay. So B. See here, first transaction is BAE. So from the root, you have to start with B. Then from B, the count, support count is 1. And A, the support count is 1. And the next item is E, the support count is 1. So with this, we have completed the first transaction, 100. Okay. So what is the next thing? BD. Okay. So from the root, you have to find the first item should be B and the next item D. Okay. So you have to increment the value of B from 1 to 2. Then a new branch for D. See here, branch for D as the support count value is 1. Now we have completed complete drawing the second transaction. Next, move on with the third one. Starting with B, and you have to draw the next item, this C. See, from the root can come up with B here. So you can increase the count of B. So it increases from 2 to 3. And you can draw a C branch. See here, C branch consisting of the support count 1. Okay. So from C you can, from the dotted lines you can make a link to the C. So thus we have completed this third transaction. Now coming on to the fourth transaction, ABD. See here from, so that is BAD, sorry. So from B, you have to increment the count of B as 4. Then you are having A here. So you can increment the count of A as 2. Then you can go with D. From A, you can have the D. And the support count value is 2. I think you might have, is there any doubt, or you able to follow my, follow this, if there are any doubts, you can ask. Is there any doubts with this? Can I have any response? Okay, let me continue. Thank you, Prabha. Okay, fine. So up to fourth transaction we have C. So coming on to the fifth transaction, you need to draw the A comma C. So see here, from the root you have to start with the A. There is no such, I think I have moved so many slides. Oh, see here. Up to fourth transaction has been drawn here. Next transaction you have to see with the fifth one. That is, you need to draw A comma C. That is A. So from the root there is no such A. You are having only B is having. So you need to go with the right subtree. A should be there, and under A you can draw for C also. See here, A. The right subtree is going to be consisting of A, then after C. Okay. So the support count is mentioned 1, and here also 1. Now we have completed the fifth transaction. Then go up with the sixth transaction, BC. So already you are having, after the root you are having B. So you can easily increase the count. Increase the count by, already you are having 4 for B count. So increase with 5. And C value you can increase here. So from B you are having here. So 5. Here you can increase from 1 to 2. This is okay. Okay, see here, B is incremented as 5 and C is 2. Okay, the next transaction 700, you see that A comma C. So again A comma C is repeated as similar to that of the 500 transaction. So you can easily increase the count of A as well as the count of C. So you might be having A count is incremented to 2 and C count incremented to 2. See here? Okay, next. The next step you have to go with the transaction 800. BACE. Now start with the rule, you are having B. So increment the value of B count as 6 and A count as 3, and there is no such from A, there is no C is there. So you can easily, so B value is incremented to 6 and A value is incremented to 3, and from A you can newly can have the branch as C count as 1, and from C you can have the count as E. See here? Fine? Are you clear with this? So thus we have completed the 800 transaction. Next, come up with the last transaction, that is 900. See here, BAC. Now what you have to do, from the root you have to track B. So increase the count value of B as 7, and the next thing, increase the value of A count as 4, then C count as 2. See here? So the orange represents a 900 transaction. Okay, thus we have completed every transaction. Thus we have constructed a FP tree. This is the final FP tree, completing all the transaction. Are you clear with this? I hope you might have understand. If there is any doubt, you can stop at this point and you can ask any queries. Okay. So the first step, we have to construct the FP tree. The second step, you have to go with constructing the database, conditional database or transaction database. Okay. So in this way, see here, this is your final FP tree. Okay. And the second tabulation is nothing but constructing the database. Okay. Okay, so with the this table, we have to start with having the minimum support count value. So which among these B, A, C, D, E, which one is having the minimum support count value? E is having 2 as minimum and D is having minimum 2. So either we can start up with the item E. Fine. So how to find the patterns, conditional pattern base? See here, where and all we are finding E, you have to go through it. So here is E and here is E. So how you are getting this two ways E count? So start up with the FP tree. From B and A, you are getting this E. So BA. So that is B comma A is depicted here. Okay. So the count is 1. The one count is for E. That should be written here. Okay. So this is one way of achieving this E value. Okay. Next path E, how you are achieving? See here, from the root B. See here, B and then C. No. B A. Sorry. B A C. Then you are getting E. So this orange, that path you are getting E. So okay, B A C. The count of E is 1 here. Support count is 1. So you have to write this. So in this way you are achieving this conditional pattern base for the E item. Okay, fine. Now find out the conditional FP tree here. So how to find this? See here, B value, the count is 1. Add up with the another set B value, the count is 1. So add these two count, you are getting B support count is 2. Likewise, A count is 1 here, A count is 1 here. So the counter to be added is A count, the final count you are getting 2. Now what are the items left out here? C. C, the count is 1, which is minimum or below the minimum support count value 2. So we have to omit that. C equals 1, which is minimum below value of the minimum support count value 2. So already the problem given is we have to check out with the minimum support threshold value 2. So if it is less than, you have to omit that particular item. So you will be containing B and A with the support count value 2. Okay. Next, see here. How to find the frequent pattern generator. So here only you are generating the frequent item set. Okay. So how to find it? So with this B and A, you have to join with the item E. So first, what is the first item? By joining B, you will be getting B comma E. Sorry. So B comma E, the count is 2. Okay, likewise, next item, what is the next item? A. So join with E. So A comma E, the count is 2. Fine. Again, you can have these two, B comma A comma E. So the count is 2. So you can have, you can generate it, the first frequent item set for the item E. With the item E you have generated. Now coming on to the D. So track from the FP tree. So how we how many possible ways you are getting the item D? So here is one D. That's all. I think no other D. So what is okay? The count is 2 here. Fine. Wait. B A D. B A D. Okay. So B comma A. That is 1. The support count is 1. And see here the another way. In the tree, you can clearly see how you are getting D value as 2. One way B, A, D. The other way from directly B, you are getting D. Okay. So, how to write the first occurrence B comma A, the count is 1. And the other way, possibility of getting D is alone B. The count is 1. Fine. So, after that, you have to find the conditional Fpg. So, how to calculate? B here 1 and here 1. So, add these two, you will be getting B2. And the value of A is 1, which is minimum below value of minimum support threshold value. So, you have to omit that. Now, with this B value combined with the D and to generate the frequent item set. So, B comma D will be getting 2. Next, coming on to the C item. So, you have to find from the C FP tree in how many number of possible ways you are getting the C value. Okay, see, here is C, here is C, and here is C. Okay. Okay. See the orange blocks, BA, you are getting C. Okay. BA, the support count value of C is 2. So, write it down. BA 2. Next possible way you are getting C is from B you are getting C. So, write B alone. The support count value of C is 2. Okay. Next, coming to this possible C value, how you are getting? From A you are getting C. So, can write it as A, support counters value is 2. So, with this, find the conditional FP tree. So, see here B is 2 and here also B2. So, the totally we are having B as 4. And A here 2 and here is also 2. You should not combine this. The reason is the left subtree is having A2. Okay. And the right subtree you are having A2. Fine. So, this is why we are not totaling it A2 plus 2, 4. Because the reason is that the A value in the left subtree is 2 and the A value on the right subtree is 2. So, you should not add these two values as 4. Okay. That's why I have written simply separated as 2 value for A on the right subtree and 2 value A for the left subtree. Okay. So, coming on to finding the frequent item set. So, combine these conditional FP tree with the C item. So, you will be getting B comma C 4 and the next A comma C 4. Okay. Next again BAC BAC. See here, with this possibility, you can combine with C. BAC, you are having 4 and 2 here. So you have always, you have to write with the minimum value, support count value. So you have to leave this 4 value. So we are writing BAC as 2. Fine. Again with this A, if you are combining, you will be getting C. So with this 2, and here also with the A, if you are combining C, you will be getting AC. 2 plus 2, you have to totally will be having 4. That's the reason why we are having A comma C as support count value 4. Okay, I think you might have understand. Okay, okay, let's move on to the next item, A. So how you are getting A, track the path in the FP tree. So here is you are getting A value. So through B you are getting this A. The count support count of A is 4. So B 4 should be written here. Okay. Next, so only single item is there. So write that B item here also. So with this combine with the item A to find the frequent item set. So you will be having B comma A as 4. Fine. And the last item is B. So B, before that you are not having any in between items are there. So it is empty set. Fine. So in this way, after finding or constructing the FP tree, you need to find the database. This tabulation is called as constructing the database, having the conditional pattern base, conditional FP tree, and frequent item set. So this is your final frequent item set has been generated with the FP growth algorithm. So this FP growth algorithm is not going to find the candidate generation. So without candidate generation, you are constructing the frequent item set. That's the main point to be noted in FP growth algorithm. Okay. So after this, you need to go with framing the association rule or generating the association rule. So already we have seen in the a priori algorithm how to find or frame the association rule. So with that, after framing all the association rule, you have to find whichever all the strong association rule and whichever all the weak association rule. Weak association rule is invalid rule. Fine. Okay. So how to frame the rule, that is yes implies I minus yes. Okay. So for that, yes, you need to go by generating the non-empty subsets. Fine. So if you're taking the frequent item set APE, so with this, find the non-empty subsets of X. X is your frequent, sorry, X is the frequent item set, and non-empty subsets of this X is A comma B comma E, and AB, A comma B, and B comma E, all these. Okay, and here you are having 6 non-empty sets are there. So with that non-empty set, you go by framing the rules. Okay, yes implies I minus S. Let's take AB on the left hand side. So minus I means AB, leaving the AB, you are having E on the item set. So E should be on the right hand side. So AB implies E. If this is the rule, next you have to find, check whether this rule is a strong association rule or not by finding the support and the confidence. Okay. So what is the confidence? ABE occurrence is 2 and 4, 2 by 4. So among these, see here, the minimum support confidence. So what is the problem given? So move to the previous thing. Okay, let's see here. I think minimum support count value is 2. Fine. So with this, among these 6 rules, So you are getting 100%. 3 rules are getting 100%. See, the minimum confidence threshold value is 70. So below 70, you have to leave all the rules. So you'll be getting only 3 rules, which is achieving 100%. So rest of the rules are invalid rules. Okay. So in this way, you have to find the strong association rule. So now we compare the a priori algorithm and the FP growth algorithm. So concentrating on the space, a priori algorithm requires more space for the data to store, and FP growth requires less space. And coming on to the time factor, a priori algorithm consume more time to generate the frequent item set, and FP growth algorithm, it consumes less time to generate the frequent item set. Okay, and coming on to the memory, it uses most of the memory in a priori algorithm. It uses less memory. I think memory and space are referring the same. No need to go by two different factors. Okay, and coming on to the accuracy factor, it is at a priori algorithm, the output or the result is going to be less accurate when compared to the FP growth. It is achieving more accuracy. Okay, so the number of scans done in the a priori algorithm is there should be a scan each candidate in the item set. So you'll be having multiple scans should be followed in a priori algorithm, but whereas in FP growth, you'll be having only 2 scans. Okay, so add some more points to this. A priori algorithm is slower than the FP growth algorithm, whereas FP growth algorithm is faster in executing the frequent item set than the a priori algorithm. Okay, and FP growth algorithm is an array based algorithm, and a priori algorithm is a tree based algorithm. FP growth algorithm required only two database scans, whereas a priori it requiring multiple database scans to generate the candidate set. Okay, and FP growth algorithm, it uses the depth first search methodology to generate the frequent item set or to construct the FP tree. Whereas in a priori algorithm, it uses a breadth first search methodology. Okay, so these are the references to prepare the slides. Thank you for patient listening. You can, if you have any queries, you can ask it. I hope you have understood two algorithms, what we have said, a priori algorithm and FP growth algorithm. These two algorithms are the main thing to find all the frequent item set. So for finding these two algorithms or main thing in association rule mining, after finding the frequent item set, you need to go by framing the association rules from it. Okay, this is the main concept that we have learned today's session. Okay, so thus we have done one association rule, two algorithms in association rule mining. That is, we have covered unsupervised learning algorithm in this session. So rest of the thing, clustering, we'll see in the next session. Thank you all. Thank you so much for patient listening. Thank you, students. We'll wind up the session. If you have any queries, you can ask up with any problems. Did you